Hello everyone, welcome to our third week. Today we're going to talk about data tidying and data import using R. Okay, so the idea of getting our data in a tidy way is like we should look to get each variable, and that's the way we should think. Each variable is a column, and each column is a variable. Additionally, each observation is a row, and each row is an observation. Finally, each value is a cell, and each cell is a single value. So these three principles, we need to try to ensure that our data frames follow this structure. Sometimes you will need to change that, depending, of course, of the context, and sometimes when you're trying to create a plot, you need to modify a column and maybe get that column into different rows. So that's what we're going to learn in this video. So we're going to learn two key functions: pivot longer and pivot wider. So in pivot longer, we take columns and we remove those columns, like from the horizontal perspective, and they will be more as rows. In the pivot wider, is the opposite. So we take some rows and we create additional columns. Okay, so let's see how it looks and how these two functions work. So we're giving an initial example here. So we have this table where we have like three patients. This is the ID, like patient A, B, and C. And there are two metrics here, or two variables. They are like the pressure. So there are two pressure types, diastolic and systolic. So that's a natural way to record data by hand. But imagine that we don't want this table in this format. Let's say that we want to change it in such a way that we have the patient ID, and then we have another variable which is the measurement, so that is the pressure type, and finally the pressure metric. Right? So we're removing these two original columns, and we're creating like a new column here, and we're combining the values. Okay, so let's see how can we do that. So we have our data frame, df. Remember the pipes. Then with the data frame, we're gonna pivot longer, because we're gonna get those columns into a single column. So let's pivot longer. So which columns? Now we mention the columns that we want to kind of like remove or combine. So in our original table, remember, the names are diastolic and systolic. So let's have those names here. And then we need to mention, okay, the values. Where are they going? So values 2. So the values of these two columns will go to a single column, and the name is going to be pressure. Like here in the example, because this is the table that we want to get. Now we're creating the code to get that table. Alright, so we run our code, and now again we have combined the systolic and diastolic into a single column, and now we have the metric, which is the pressure. So this is a different format compared to the original table. Again, this is useful when sometimes you want to create like a new plot, different plot, and you need to rearrange your data in order to match the requirements. Okay, so let's use another example. So in this example, we're given this table. So it's we have the 3 students, test 1, test 2, and the grades. So we wanna combine like a single column, and in the single column we have, okay, which test was that, like number 1, number 2, and then the third column will be the grade. So it's like a different variable. It's just one variable instead of having the two variables here. Okay, so in this one we're gonna do something different, and we'll show you that in our second attempt. So let's do our first try. In the first try, we will follow like something similar to what we did in the previous example. So we have our data frame, and then with the data frame, we want to pivot longer. The column names, so test 1 and test 2. The names are important. You need to ensure that you have a perfect match with the names. If you have uppercase and things like that, be careful. Test 1, test 2. Alright? And then values 2. You want to get the values, the number column. So we're going to call it score. So now we have one column. Please notice that it's giving like a random column name here, name. We can change that. And names too. So let's give like which name you want to assign here. So let's call it test. Okay, so now we have ID test, test 1, test 2, and the score. So this works. This works. But let's say that we want to get rid of this like test underscore 1. So instead of like test underscore 1, test underscore 2, you just want 1 or 2. So we want to remove this part. So we can do that from the code here in pivot longer. So in order to do so, in names too, I need to make some changes. The names too. Now we are gonna have this special code here. Is this one. So in the names too, we're gonna use dot value, and then num is like the number. So what it's gonna do is that it's gonna split the column names into two components. So the first part, it's gonna be the output of the column name, and the second part is gonna be the number. So let me show it to you. So in this one, we say okay, we're gonna split it. Then I'm gonna call one of the columns test number. So this is gonna be 1 or 2. So what's gonna happen is like the value is gonna be to the first part of the word, and the column is gonna be the name is gonna be test, and then the second part is gonna be the test number. So the second part will be whatever it is after the low dash here, or the underscore, whatever is after. So this number 1 and this number 2. But of course I need to add one more parameter here to let R know that we have the underscore here. So after the underscore is gonna split the word into like the part before, that's gonna be for the value of the variable, and then this number, what is after the underscore, is gonna be what's going to the column test number. So we need here the names sep, it's another parameter. Now this is not needed. So name sep, this is going to be our low dash. So again, what we're saying here is, okay, you're going to take these names here, and you're going to split it in two parts, depending of what? Of the separator that I have added. So there's one part before and one part after that separator. So from the first part, test, the word test, that will be a column with the test grade, with the grade that the student got. And then the second part of the variable name, which is in this case the number, is going for the new variable of this column, the test number. Okay, let's see how it works. I did it here, but it's better to run it here to compare. I'm missing here my parentheses to close the pivot longer. And the df. Yeah, I didn't take the whole thing. So it's df. Alright, so now we're splitting, instead of having like a column with test1, test2, remember here test1, test2, so now we just get the number, the 1, this is the character that is after the dash, and the 2, and the first part of the column names, test is given or is assigned to the variable. This is the grade. This is the grade. So it's doing what we wanted to do. Alright, so let's solve a more challenging problem. In this one, we're given this table. In the table, so let me explain the context a little bit. So it's about families. So there are 5 families. And these families, they have 1 or 2 children. So what information we have? We have the date of birth of child 1, date of birth of child 2, the name of child 1, and the name of child 2. That's the information that we have. So the whole idea of this problem is like we wanna make it simpler. So okay, we want the family number. We use one child, so child 1 or child 2. That's one column. And instead of having 2 columns for the date of birth, we use 1. And then instead of 2 column names, just like 1 column with the name. So we want to combine these 2 and these 2. That's the idea. So family is going to be the same, but the remaining 4 columns, they are going to change. So we want to combine again the date of births and the names. Please note that there is a structure here. For example, for the date of birth, so the first part is the same. Then we have the low dash, which is same structure, and then we have child 1 and child 2. And for the names, there is a similar structure. So the idea is just to keep the first part, and then we want to create a column with the information of child 1, child 2, which is going to be useful also for the names. Okay, so let's do that. So the name of the data frame is household local, and then with that data frame, we're going to pivot longer. The columns here, we want all the columns except family. Remember the other 4 columns except family. So this is when we have this symbol here, that's like everything except that. So except family. Now names too. And we use the same idea. So remember, with the value, like dot value, because we want to split the variables name, and we need to assign one name to the part of child 1, child 2, which is the second part. So I'm gonna call it birth order, child 1 and child 2. This is just an arbitrary name. Alright, we need to specify the separator. The underscore here. So let's run it. So please notice that now it has combined the date of birth, the names, and there is a variable birth order. That's the name that was assigned, where we have the information of child 1 and child 2. So remember, the names too is splitting the original variable names into. So the first part is here for these 2 columns, date of birth of child 1 and date of birth of child 2. So since they have the same like first word, they are combined. And then with the last two columns, since they share the same name here, the first part, so they're combined together. And then what is after the separator, it goes to the birth order. So that's child 1 and child 2. So this is the resulting table, which is easier to read compared to the original one, this one. Alright, so for period longer, let's do one more example. This one is a little bit more challenging in terms of like it's bigger, our data set. So let me give you some context. So this is for the World Health Organization. It's a tuberculosis report where there are like around 60 variables, but the challenging part here is like from column 5 to column 60, like the variable they have like a structure. So the name is like new, low dash, then there is like the method of diagnosis. So there are 4 alternatives. Then there is another dash, then we have the gender, and then there is another dash, and then we have the age group. So let me show it to you how it looks. Like this. So new, the diagnostic method, then we have the gender, and then we have the age. So that this is the first data set. Now there is a modified version in the same package, which is called WHO2. It's the same idea. They just rename the variables and remove some of the variables. Because in the original data set, for example, there was not like a low dash here between the gender and the age group. So then that's difficult to separate, right? Because there is no a low dash here. But in the second data set, we have the dash here. So we can use the structure. We have the diagnosis, gender, and then the age group. So it's easier to split. So let's do that. So the idea is like instead of having like these multiple columns, I don't want like this like SP, SP, SP. So I just want like the diagnosis to be only one column. So some of them will be SP, other will be rel. Then the gender I want it to be another column, and then the age group I want that to be one more column. So we're going to keep country and year the same. We just want to combine some of these informations. So we want to make our table longer. We want to pivot longer our table. Okay, let's do that. Let's create a modified version. So for that we take the second data frame, not the first one, the second one, type, pivot longer, so for the columns, we want everything, we want to combine everything except country and year. So we specify that. So we want to keep country and year as they are right now. And then, since the other the structure of the name of the columns, it has like 3 parts: treatment, gender, and the age group. So names too. It's simple. So we want to create the 3 new columns. So we want to have the diagnosis, which is in the first position, then the gender, and finally the age. So we need to specify that there is a separator. So name sep equal to the low dash, And of course, let's specify the variable values too. So the original values are going to a new column, and the name is going to be count. So that's the original variable. We're just giving a name to the values. So now we get a longer table. So where one column is diagnosis, gender, and age. So instead of having like all of them combined, and the count is the variable. Don't worry about the NAs. Actually, they were originally in the table. You can do a summary and see that there are some values different than NAs in our data frame, like here, for example. So it's working. It's working. The method is working. All right. Let's continue. And now we're going wider. So instead of going longer, let's pivot wider. So let me say first that typically, like the function that we just covered, it's like more popular. So most of the time you want to pivot longer, but pivot wider is another option. It's less common, but it's still possible. It depends what you want to do. There are no like rules in general. But again, this one is like less common. All right. So we're given this table. So in here, the data, we have information about 2 patients, and there are like 3 measurements of the pressure. So there is like method 1, method 2, and method 3. So here, the idea is to create like a single row per patient. So it's like the opposite as the first problem that we solved. Again, that depends of the context. There is no like a general rule on how you should have your data. There are some, of course, guidelines, as I mentioned at the beginning of the video, to have like to keep your data tidy. But again, at the end of the day, it depends on the type of analysis that you're trying to do. Okay, so let's pivot wider in this case. Again, I'm gonna create like only one row per patient instead of having like 2 or 3 rows like in the table. Okay, so with that data frame, let's pivot wider. So the names from, it means like from where we're going to take the names of the new columns. So in this case, from the column measurement. So the new columns are going to be like BP1, BP2, and BP3. That's the names from. And then values from means like from which column you're going to take the values. Here, pressure. So this now our table is wider. So we have 1 row per patient. Patient A, we have the 3 measurements, and for patient B, there are only 2 measurements. This one is not available because in the original table, that value wasn't there. For patient B. All right. So let's look at a larger example. So in this one, we're going to use information from a hospice provider data. So it's a customer service like survey. So there are some metrics about like the customer experience, the patient experience. The name of the data frame, it's CMS patient experience. So we get the ID of the organization, the name of the organization, and this is the metric, the measurement. Then we have like a measure title, like a description of the metric, and of course the value of the metric. For example, how well providers communicate. In this case, this one got 87. I guess this is from 0 to 100. You can always check help, remember? So it gives you like a more detailed description of the variables in case you need it. Alright, so let's continue with our problem. Okay, so the idea here is like we wanna get this matrix. So instead of having like for a single provider these multiple metrics, we wanna add them as columns instead of like multiple rows. So let's do that. We're going wider. So it's that CMS, the name of the data set, the patient experience. Be careful because there is like a similar data set. And then with that data set, let's pivot wider. So we're taking the names from measure CD. That's the name, let me show it to you. This is measure CD. We want to take those to the columns, and of course we want the PRF rate to be the values. So values too. We're going to use that key variable. I'm sorry, it's values from. PRF rate. Okay, so now we have added all the variables here in the columns for the different metrics, right? And we have the values. Now the problem with our table, if we look at the table right now, and we don't want that, it's like we still have like multiple rows for the same organization. For example, this one, USC Care Medical Group, it's like 1, 2, 3, 4, 5, like several times, one per metric, because there is also a measure title here. So that's not ideal, and that's why we have like a large number of NAs here in our table. So we don't want that. So we want only like one row per organization, right? So the information that we get from these two initial columns is useful to combine the rows. So we're gonna have like a unique ID per row. So I don't want like this information like to be repeated several times. So let's do that. Let's combine this. In order to do so, I'm gonna copy the previous code. I'm gonna paste it here. And let's add an additional parameter, which is going to be the ID calls. So the ID of the columns, and we're going to use in this case two columns. They are going to be our IDs. So those are the first two, and they have the common thing that they have. If you notice, is like at the beginning they have the ORG, so they contain that word. That's why we're using here the starts with the organization ORG. So now what's going to happen is that it's going to the pivot wider is going to ensure that you don't have like multiple rows for the same ID. I'm missing a comma here. So now it looks better. look for the first one, the USC Care Medical. So instead of having multiple rows, now we have just one, and now we don't have the NAS, the non-available observations like in the previous one, because like at least the same amount, because now we're combining all the metrics as it should be. So this is a better result compared to the previous one. So only like one row per organization with all the metrics that were provided during the customer experience analysis. Okay, so let's go to the last part of this video. So far we have learned how to use the pivot longer, pivot wider, but now let's check some basics in how to import data, which is really important. So we're giving here an example. In this one, we're going to analyze, this is a small data set for students. So the variables are student ID, full name, the favorite food, meal plan, and the age of the student. Now, this data set, it's coming from this web page, POSIT. Now, if you're working, if you have this file in your computer, so here using this function read.csv, so you just need to copy the path here. So instead of the link, if you copy the path in your computer, that will be enough. Or if you upload the file here in Colab, in Google Colab, the place where you upload the file is here. So in this folder, here you have the upload option. You find the file, you upload it, and then you can use it just by copying the name of the file .csv, and that should be it here. It's not difficult. We will do that like all the time when we're working with R. Okay, so I'm going to run the information. Let's see the data set. Students. So only 6 students. And there are some problems with our data here. For example, we have some missing information here. In the age here of this student, the student number 5, instead of number, we have like the word 5. That's possible. In real life, that's possible, you know, like when you have like different people typing data in the system, so these things can happen. Alright, so an alternative to read.csv, this is a like RBase. Now from the tidyverse, there is the read low-csv. It looks similar. It has the same structure. Maybe it gives more information. And now let's view our data. So please notice that in the previous one, there was an empty value, but it was the table wasn't like suggesting like an NA, but here the tidyverse function detected the empty value and added an NA here. Now the problem with there is another NA, but the format is different because that's the way in which someone typed that in the original data frame. So later we will take care of that. All right. So now there is one question. Can you find the age of the average age of the students? So let's see first that by all the students. From the students, let's analyze the age. So several things here first. We have quotation marks, meaning like this is text. We have a non-available value. We have like the word 5. So there are a lot of problems here in this column. So some things that we can do to fix this. If you try to compute, of course, the mean of the original column, you will get an error. We will get an error right away, like this, return A. That's a problem. So there are some things that we can do. For example, we can transform that column to an integer. So we get integer values, and then we have NAs for the text and the empty values, and then you can compute the mean to that. So let's try to do this. Mean of the integer values. There is an error initially because there are NAs in our operation. But here you can add NA, this is a parameter of the function NA dot rm, which is like remove, NA dot remove. So we say true. That means like for this specific operation you remove the NA values. And of course we get the average of the remaining four values. So this is one way to do it. It's not perfect, of course, because we're missing some information. For example, the 5. There, you can transform that. I mean, if you notice that there is a pattern, let's say that we have a bigger file, a bigger data set with more students, and then you notice that consistently, you know, there are some of these the numbers, they are like written using words. So we can create some conditionals in order to take care of that. But in this case, it's just one. So it's not a big deal, but again, if you see like a pattern, it is possible to fix it. Okay, now for the NAs, so, and this will be the last thing in this video, remember that, for example, here, if it's empty, the read load dash CSV was able to find it, but here it is as a different form. It's difficult to identify that this is an unavailable value. So we can specify that in the function when we are importing our data. So here, for example, in the read CSV, we can mention like there are NAs, and we can specify all the possible ways in which they appear. So you can say, okay, be careful because when I see some of the NAs, I'm sorry with it. All right, it will be like this, and others will be only empty values. So with that, you're providing more information. So next time when you read it, oh here, I'm sorry, I have an extra equal sign. But right now, remember that this one was not detected, now it is detected because we provided more information to our function. So our function was able to identify the NA value here in this one. So these are only some simple ways in which we can import data. This is a CSV file, comma separated value, which is a popular format when we are importing files. Typically in Excel, you have the alternative to save your data, your file, as a CSV. So it's a common file. I'm pretty sure that in the upcoming assignments, we're going to use some CSV files. All right, I'm going to stop the video for now. I'll see you in the next lecture.